So yeah, sorry, going back to classes and object-oriented programming. Object-oriented programming is kind of like a paradigm that many programming languages follow. Like Ruby is a object-oriented programming language. Has anyone ever seen that term when you like read about Ruby? Yay, nay?
Yeah.
I first learned Java and C++, so yeah.
Java, yeah, Java is an object-oriented programming language. It's been a while. I
C++
barely,
wasn't supposed to be, but the course I was taking used it. It was weird.
yeah. So there's a lot, like Python's object-oriented, Java's object-oriented, C# is, JavaScript is like, JavaScript's like a weird version of it, but it's object-oriented. Yeah, so it's like a common paradigm where the idea behind it is it allows for you to write, kind of create your own objects, or what we'll call classes. And you can think of a class as just a way, it's kind of like a blueprint to like describe something in the real world. So if we were looking at like, we wanted, and don't kind of get this confused with like Rails models. I mean, technically Rails models are classes, but just kind of think about this in Ruby where we're not using Rails. Classes are really meant to describe like real world objects. So if you had something like, let me pull up VS Code for this. So I'm just going to open this. Let's go ahead and I'm going to make a directory. CD into that. Code. Let's do a new file. Let's just call this classes. Okay, so let's say like we had a car. Now a car might have some characteristics, right? Like a car might have like mileage, right? It might have a year that it was built. It might have, what else? A make.
Engine type.
Yeah, engine type, like engine.
2 liter, 3 liter, things like that. That's what they usually go.
Yeah, so there's a lot of characteristics of a car, like attributes. There's also like cars have function, like there's functionality to a car. Like a car can turn right, which would be like a function. It can stop, it can go, it can turn on. So we can think of a car as kind of like, this, blueprint, or the class. As we get into classes, we can think of like a class as a way to create like a blueprint of a car, where we can create cars where, cars are going to have mileage, year, make, model, and then a car is also going to have this ability to like turn right, to stop, go, turn on, things like that. So that's object-oriented programming in like a nutshell, like a really quick intro. And it's a really popular paradigm because the more we can kind of abstract our code, from like the nitty-gritty code, and make it more like it is in the real world, it makes it easier to program, because now we can think about our code like we think about things in the real world. It's a lot easier to like create a car and then say like car.turn right than, writing memory addresses in binary. Like, so there's just levels upon levels of abstraction that make code easier to write. I don't know if you know, it's like, so all programming languages get like translated to zeros and ones. Like, it's kind of crazy to think about. And before that step, there's usually something called like machine language, which is like really low level, like it's like go to, it's all these weird commands of like addresses and like, but it's a little more English friendly, like not much, but you can tell it to like go to places. You can tell it to like add this memory location to this memory location. So that's like machine language. This would be binary. So it's easy to translate machine language to binary, and it's a little easier like for humans to read, to write machine language. It's not that easy. Then you have something like maybe like C, which is a pretty common language, where it's like you can do like if statements and you can write functions. So that's nice. And then that can be translated to machine language. And then you have something like, you know, Ruby that allows you to do like object-oriented programming. So as we're like going up this chain from like binary language, machine language, like a low level language like C up to like Ruby, we're writing code that's more human readable. And as you go down, you're getting closer to like the hardware. So you have a little more, you have a lot more control and power of like exactly what you're doing. But we like, I mean, I like Ruby, like languages like Ruby, because it allows me to think like a human and not a computer, which I'm much better at doing. So I think the best way to kind of just learn some of these concepts is just to code them. So let's go ahead. You can follow along with this. And let's kind of look at objects in Ruby and object-oriented programming. So let's start with a class. How do I define a class in Ruby? So to define a class is pretty simple.
Is an object and pretty similar to a class, or like a model pretty similar to a class?
Okay, so let's not, I know this gets confusing, so let's not talk like, so right now we're talking Ruby verbiage, Ruby language. So when I use the word object, do not think of JavaScript. Right?
I didn't mean to say object, I meant model.
No, but I'm going to say this. I'm going to say everything in Ruby is an object. That's not to say like it's a key value pair. It's like what that means. It's like it's derived from a class. What is like this called in Ruby? This is not an object. I mean, it is technically it's an object because everything in like this is like a numbers an object, a string's an object in Ruby. So this technically is an object because everything's an object, but what type of data is this in Ruby? What do we call this? Like our key value pair. This is a hash. So that's a hash. That's the word. This is a hash. You know, in JavaScript, this is an object. So when I'm talking, you just kind of got to ignore this word. Like what you know about JavaScript, the word object is different than Ruby. So everything in Ruby is a object, meaning it's derived from a class. So one is a object, a string is an object, and so forth. So these are classes like hash, strings, numbers. Those are classes defined by Ruby. So there are like Ruby defined classes. And that's going to be stuff like, hashes, integers, etc. But the nice thing about object-oriented programming language is we can define our own. And that's what we're going to do right now. So let's say I want to define like I want to create a blueprint for like a person. So how do I define a class? So let me just put this comment down here. Class and then name, and like that's how you define a class in Ruby. If I want to define a person class, I just do class person end. And then I can declare a person. Let's just say Bob equals person dot new. And then let's do a puts Bob dot class. I can like write this, I can interpolate this and say like Bob is a, and then log the class of Bob. All right, so let's do Ruby classes.rb. Bob is a person. Let's just say 1. So if I do puts like 1 dot class, 1 is a integer. So we have these predefined classes in Ruby, and we can define our own. All right. And then you want to do this one. Let's just show this one. So let's do Sally. Let's kind of maybe look at the difference between like, I think so we can look at the difference between like a hash and a class. So let's create a hash. Give Sally a name and an age. And then like Sally is a Sally.class. So Sally is a hash. Bob is a person. 1 is a integer. So when we say like everything in Ruby is a object, what it kind of like, in a sense, I can call the dot class on everything in Ruby, and it will tell me what kind of object it is. And we can define our own. Cool. So actually, I'm going to move these. I'm going to move these up here so they're not in the way of this demo. So here are some Ruby defined classes. But yeah, now we can define our own. Comment these out so we don't. All right, so Bob is a person. Well, this isn't too special, right? Like I want to maybe like, give Bob a name and an age. So let's see how we can do that. Let's start giving, this person blueprint, like some attributes. So what I can do inside of here, I'm going to call this and I'm going to create a method called initialize. Now this I have to call initialize, and I have to spell it right. because this method gets called when a instance of person is made or is created. Let's just do a puts method. Now I'm not calling the initialize anywhere, right? I'm just defining it. I'm not calling it, but notice when I run my code, I get this message, initialize called. If I comment out line 25, I get this error. I comment out that one. Initialize is not called. Calling the person.new, that calls the initialize method. So if I do this new call twice, I'm going to see this initialize called function called twice. So now what I can do is I can pass this, some param. So let's do Bob. And let's do like an age, 34. Let's do Tony. Tony can be like, I don't know, 14. So now in my initialize method, I can, take these variables, X and Y. Let's just call them X and Y. Let's just do a puts message right now so we can see these X and puts Y. So X is Bob. When it's Bob, X is going to be Bob. When it's, 34 for Tony, it's going to be Tony and 14. So I'm just calling a function. It's kind of weird that they don't call that initialize, person.initialize. It's like different name, but just know when you call the new method, it calls the initialize function in your person. So what I can do here, and let's not call these X and Y, let's just call this name and age because that's what they are. I can come in here and I can create an instance variable at name equals name, at age equals age. Okay, so now I have Bob is a person. Let's try doing this, puts bob.name. So what it's saying, undefined method name for person. Okay, so I can't just grab this instance variable. But maybe I could do something like this. I could do like an about. And I could say, I am going to use this. I don't have to use this word, but let's just use it right here. Self.age. Let's use self.name. And I am self.age. For now, let's switch that to about. Oh, it does not undefined method name. Oh, it doesn't, still doesn't like this. Let's just do the instance variable right now, and then we'll go back to this. Okay, so let's do our instance variable. So I can do this about, and then I can grab this instance variable now. So I don't need to say Bob is, I can just do puts Bob about here. Hi, I am Bob and I'm 34. So I can call this about method on Bob, and Bob's going to use this at name and at age variable. But yeah, as we saw, like I can't, if I try to just grab Bob's name directly, it's going to say that's undefined because it's thinking it's a method. So what I can do is I can create some what are called like getters and setters. So I can do this. I can do like an attribute. So and this is a Ruby method, accessors. Accessor. And I can say the things I want to grab. So maybe I want to grab name and age. So I'm going to say in a comment at ATRR, you know, accessor, this makes our instance variables readable and writable. Does that mean? Well, now if I try to run Bob, like ATTI, I spelled that wrong, accessor, two S's. Yeah, so now I can access their name. And I could also go ahead and change the name or like the age. Wait, that was the same age. So, you know, when I create Bob, his age 34, but then I can assign it to age, like 35. Let me show you some other one of these. There's a attribute reader. So let's just go ahead. I'm going to do this. I'm just going to put name as accessor, and I'm going to do a reader with age. This comment right here. And then the attribute reader now it just makes our instance variable readable, not writable. All right, so if I try doing this now, I get an error. Like it's this undefined method age for Bob. So because right here, I'm saying age is only readable. When I do attribute accessor, I'm saying, you know, these things are readable and writable. This one's only readable. So I can like grab Bob's dot age. I can change his name. Does that like make sense?
Is there any reason why you would use a reader instead of an accessor?
Yeah, we're not gonna like, we won't get into the.
This just seems like a one's better than the other sort of situation.
No, it's more like it's not like a black or white thing. It's, do you want people being able to change your age? Like maybe I don't want anyone to be able to change the age because I don't want someone coming in here. And when I like, it could even be like yourself. You're doing it because you don't want to like allow yourself to accidentally change the age of a person. Like sometimes it's not like this malicious thing where there's like some hacker trying to change your age. It's like maybe you're writing this library and you're trying to protect yourselves and the other coders from changing the age. Because you maybe you don't want someone coming in here and saying like bob.age equals -11. Like you want control. but you don't mind if they read someone's age. You know, maybe I have like a password in here. And I don't want anyone to be able to like, you know, read this password. So I wouldn't even throw it on here. So bob.password, you know, it's not going to allow me to see that. So I can't, you know, grab that password outside of my class.
Okay, I get it.
But I can use that in my, I can use it in my class. I can use this instance variable. My password, you know, is, you know, I might not like show my password, but I could do something like, I mean, maybe hash it or .length. So I can still use this password variable in my other functions, but then they can't access it. So I need to like, can't do that. That doesn't work. Undefined method length. Is it so high? What? I thought password. My password is 8. I can grab the length of that. All right, let's keep going with this little example. I just want to talk about now that we have these instance variables and we have these accessors, let's do about the self. Let's just do another one. Hi, I am self. Let's just see what this puts. Okay, so we create a new person. We got Bob. Let's go ahead and puts like Bob dot about the self. Like what is like this self keyword? Like, hi, I am person. Hi, I am person. I am self dot name. And self age. Just show this. If I try to do self dot password, that's like not gettable. So I can't actually grab that because password's not a method because I haven't set that as a method, but I can grab the name method and the age method. So this isn't the at age instance variable. This is like when I do this attribute accessor, it's creating this method called name. It's creating this method called age. It's not the instance variable. So self is the instance of the class calling the method. Does that sentence make sense? So Bob right here is calling about the self. So self right here would become, it's this Bob person. So Bob is a person. Bob's name is Bob, and Bob's age is 34. If I have Tony here and puts Tony about the self, self now becomes, it's the instance. So Bob and Tony are instances of the person class. And they are self dot, and they have names, but their values are going to be different. They have ages, but their values are going to be different.
Where does the word self come from? Is that a Ruby?
It's a reserved word in Ruby. It's a very special, like in JavaScript, it's going to be this.
Oh, okay.
So yeah, you might know that from Java. It's the this keyword. In Ruby, it's self. They named it self. So yeah, this is a reserved word in Ruby. It's kind of like can kind of be a very confusing concept. That what is self? Well, it's the thing calling the method. But we can also have what's called a class method. Let's just make this more, not just different context, because now self is going to be something else. So I want to do a class method. So I'm going to do, I'm going to use this self dot. So self here refers to the class. So let's do a self dot about. So I have two about methods, right? I have an about. So this is what is called a instance method. Called on instance of the class. And here I have a class method, which is, we use the self dot to define a class method. And yeah, self here refers to the class. So when I'm calling an instance method, I'm calling it on the person, on the instance of, like I'm going to be calling it on Bob or Tony. When I call a class method, I'm going to be calling it on the class. So puts person dot about. Now this would kind of, if I'm talking on a class method, this is something that would like be true for all my people, or kind of would be something like, it's not really specific to, individuals. It's kind of about people in general. So I could say like, we are mammals, and there are 8 billion of us. That's something like some information about people in general, right? If you're a person, like this is like true for you. Like I'm a mammal. Yes, there's 8 billion of us. We live on Earth. So then I call it called on class. So we have our person dot about, but then we also could do our Bob dot about called on instance. Does that make sense? I think this is probably one of the most important things to grab from this lecture is kind of this concept. So a class, we're kind of creating this blueprint, and from this blueprint, we can create instances, actual like instances of that class. So think like a person, the idea, the blueprint of a person is kind of like an abstract idea. Like it's a blueprint. But to actually make one, I'm going to make a new person. And here I can come in here and give birth to Bob. Like Bob is now a person. Tony is now a person. And Bob and Tony are different because, you know, they have different names, they have different ages, they have different passwords. But Bob and Tony are people. So I could have a method like, you know, that's very common, like that every person does. I'm still going to have this be a instance method because it's something individuals do. Let's just have like a breathe in function, right? Every person can breathe in. If you can't, you're not going to be a person for too long. So this is where I can share this logic between the instances of my people. Like breathing's probably a pretty complicated thing, but I can you know, write this function once and then, you know, call it on, you know, my instances. I can say, hey, Bob, you need to breathe in. Hey, Tony, you need to breathe in. And then I could do like once again, I could use the at name or the at self dot name. Oop, I need to flip that down. Is this any questions on like just kind of the high level concepts of this? Does it kind of make sense why this is like such a powerful programming paradigm and why like a lot of languages, you know, choose to make themselves object oriented? Because now I can create this scaffold, this person class. It's very like intuitively, like this makes a lot of sense as far as like reading this code. I can start to think about my code in more like the way I think about real world objects, which makes coding easier.
I was late this morning, but I think I'm, from what I've even seen, I think I can understand it.
Yeah, cool.
Sorry about that, by the way.
Oh, you're fine. It happens.
Yeah, it's just, I think it's the names that throw us off. You know, a class, you think of a class as a class or not. If it said it was a definition and a product instead of, you know, an instance, the product of the definition, I think it makes more sense. But the hardest part is just kind of getting the terminology.
Yeah, and I mean the class, the class is actually pretty common. Like I think in all, I don't know a language where it's not called class. So at least that's consistent. But yeah, I mean, when we get to like JavaScript and like we're talking about objects, that gets confusing because an object, the word object is something different in JavaScript and Ruby. When we get to JavaScript, we're going to be using the this keyword, which is always fun to try to explain the this keyword. And like they do have like there's certain things that are very similar, but like different languages are going to have like their different flavors of how they implement object-oriented programming. but you learn one object-oriented project, you learn kind of the concepts, and you can really apply them to all programming languages. So one thing that like some kind of concepts with object-oriented programming are encapsulation. And then, so we're kind of encapsulating the data of our person here. There's going to be another big one that we're going to look at right now is inheritance. This is another powerful thing of object-oriented programming. So let's look at this. I'm going to just, let me Slack out this person so I can like maybe just delete this or move to a different file. I'm going to just do another file. I don't really care what I call this. Okay. So let's just kind of look at like a very intuitive example of inheritance so that we know all so well. Like, so let's say we have a parent class, and we're going to have two classes and we're going to do inheritance. Our child's going to inherit parent. So when I do this in Ruby, this sign, you can think of this saying like, you know, child. You'll hear a couple terms like that. Child extends parent. This is just like child. Child is inheriting from parent class. Okay. What does that mean? Let's just kind of look at this. So let's go ahead and do our def initialize, and let's just do this. Let's do a puts parent initialize called. And I'm going to copy this one. And let's do a child initialize called. And let's do parent equals parent.new and C equals child.new. I need to, okay, let's go ahead and run this Ruby demo 1.rb. Okay, so right now, nothing's really going on. I just create a new parent, so that's calling the initialize method. I create a child method, that's calling the child initialize method. Could also do stuff like this. We could do puts like p.class. Inputs c.class. So that's a parent, that's a child. So what this is useful for is I can come in here and I can define a method in my parent. Let's just call this shared logic or shared, whatever. And I'm just going to call this put shared called. So notice in my child class, I don't have this shared method. But I can, on a child component, I can call the shared. Let's just not do this. I'm going to return. Just go ahead and run this. Keep on getting rid of my terminal. So I can run this shared. So shared is called. Now notice, like I'm calling this on my instance of my child. So I can call, since my child is inheriting from my parent, I can call this shared method. So let's look at, so I think this is a good way to think of it, but this is a little too like generalized, like a child inheriting from a parent. Let's look at kind of going back to our person where we could maybe use this. So let's say instead of like, I'm going to call this mammal. So it's kind of like, think about like a real world example. So let's say I have like a mammal class. And I'm just going to call mammal initialize called. And then we can have like a human class. Now a human is a mammal, right? So I can say a human inherits from a mammal because a human is a mammal. So what's something that all mammals do? Can anyone think of something? Or like what they have, or
All mammals have hair.
hair. Okay, yeah. So let's do like, so in my initialize, I mean, let's just make this like really simple and just say, let's just, I mean, this is not true, but they do have hair, but let's just say like they have like one hair color because they all have hair.
Okay.
So I'm going to say, hey, okay, let's give all mammals a hair color. Oversimplifying it, but what's something else, all mammals do? All mammals breathe in, right? They all, or they can just breathe. So it's just breathing. So, in my person class, I had this breathing method, but maybe I can move that up to like a higher class of mammal where all, because maybe I'm going to create like a dog class, and I can put that breathe method up into both this mammal class, and then, my dog and my human can both breathe. So what's kind of something a human has that like not necessarily all mammals have? Like I don't know.
Speech.
Speech, I mean.
Opposable thumbs.
Opposable thumbs. Don't monkeys have thumbs?
You said not all. Yeah, they do, but you said
Yeah,
just one.
I guess, yeah, it could be like, I don't know, let's do like a degree. Or like level of education, right?
Okay.
It doesn't have to be like, it could be things, but like, let's just do education. So now my human, so when I'm declaring my initialize like these things, it's going to be like, what does every mammal have? Like I wouldn't want to define something like, like opposable thumbs here, because not all mammals have opposable thumbs, but I could do that here because humans do. And then I could go create a chimpanzee class and they could have it too. But let's just use education level. Let's do this. Let's do like occupation. That's pretty specific to people. Okay, so then I can like come in here and I can say like at occupation equals occupation. Like something else that all mammals are going to have, they're all going to have like an age, right? Everything has an age. Every mammal has an age. But, a human might have like specifically an occupation that maybe we want to expect most of our other mammals to have. Cool. So I'm going to get rid of just create, like, I'm not going to create a mammal. Doesn't in this, it really doesn't make sense to create a mammal because I'm using mammal just as kind of like this class to share characteristics. Like I can't really have a specific mammal. Instead, I'm going to have a like more specific version of a mammal, like a human, but I'm going to use the mammal class to share some logic. So when I create, Bob again, let's create Bob again. So Bob is now going to be a human.new. Now I need to pass the occupation. So Bob is a, he's a kite flyer. That's an awesome occupation. And then, up 21. So let's do a ATTR accessor, and let's just do that for occupation. So yeah, now I can do Bob.occupation. Okay. Spelled this wrong again. Oh, it wants my age here, age. So it's saying, hey, initialize wrong number of arguments. So Ruby's doing something that JavaScript doesn't do. If I don't give it the right amount of arguments, it's going to throw an error. It's like, hey, this initialize, or you're calling this with 2 arguments. The initialize method only had 1. So go fix that. So let's define this to have another one. Okay, I'm not doing anything with it, but I defined it. That made Ruby happy. So Bob's a kite flyer. But I'm not calling this initialize method, and like I need to get the hair color and age there. So I need to actually call this initialize method. And we actually are going to want the hair color here too. So how do I call this method? Well, there's another word, keyword, super. So super calls the method in the parent class. So let's just run this and see what happens. So I just call super, run this again. Well, now it's saying, hey, wrong number of arguments given, given 2, expected 3. So once again, I just defined this hair color thing in here. So now I need to actually put in this. Let's do brown. So now I'm giving this 3 arguments. Now I'm getting another error for the same thing, wrong. Well, it's a different place, but wrong number of arguments given 0, expected 2. And that's right here, line 18 in my initialize. So it's trying to call this initialize method, but this one wants 2. Oh, it wants the hair color and age. So hair color and age. So that works. I got rid of the puts in here. Show this. So mammal init called. So this super method is calling that method in the parent class, the initial method, initialize method. So then in my mammal class, I can go ahead and like do the attributes accessors here for hair color and age. So I can now do bob.age, bob. And Bob can now breathe. Okay. So let's look at, so let's now like reuse this class. So let's kind of see something different. Let's come in and create another mammal like a dog. So a dog is also a mammal. But you know, a dog doesn't have an occupation. What's something that like a dog has that amount? I guess the question, what's something that like a dog has that not all mammals have?
Tail.
Tail. Cool. I mean, tail length. So yeah, so now I can like do like something like tail length. Except don't all mammals have like at least like a resemblance of a tail? I don't know, but yeah, that's a good one. So we'll do tail
What if
length.
he's a seeing eye dog?
What?
What if he's a seeing eye dog?
Seeing
It's just a dog.
Or a snow patrol dog?
I
They have
can't.
an occupation then if they're a seeing eye dog.
Yeah, that's a dog could have an occupation. I guess you could have like a hunting, but I don't know. Like if I was
Dogs don't pay taxes, but there's something that's unique about them.
Yeah.
tail
But-
length, I think that's pretty, that's good. Most dogs have tails. Let's just give them the length. So yeah, now I can come in here at you know, dog, I can give it something specific to that. And really it's like, it comes down to like your app, what, you know, you can create these specific things for, you know, your dog or your human, but they both are inheriting mammal. Because maybe you want both your humans and your dogs to have like a hair color and age, and they both breathe. Sweet. So yeah, and then they can have their own methods. Like a human can like work. And you know, going to work. Or like a human can code, like coding now. And like a dog can go ahead and like, I don't know, fetch. I can reuse this logic of the mammal. I can create new specific attributes for like my specific models or my specific classes. And that's just kind of like inheritance. So I can put a lot of the logic in like what mammals do in this one class and then create subsets of those classes. And that's actually, we see this when we do our Rails model, is we inherit from like the active record class in Rails. And that gives us all of like, because all of our models, we want to be able to create to the database. We want to be able to update to a database. You know, we want to be able to, you know, delete from a database. So we can take all that logic, put it into one class, and then inherit from that class. And, you know, the Rails people were nice enough to do that for us, so we don't even need to write the code. We just need to do like, you know, our dog extends active record, and boom, we have all of that functionality from active record. So that's what we do in Rails when we do like a Rails G model dog. You know, we're going to inherit, and this code is generated for us where we inherit from active record. We'll just kind of visualize what it's actually doing by creating our own class called mammal. Sweet. Does this make sense? I want to like, so let's say there's maybe a like both dogs and humans can talk, like speak, right, in their own way. It's a little different though. What I can do is I can define a method inside of here call it like speak. And then I can have this throw an error. So I'm going to do like a raise. This is just going to cause it to throw an error. Well, actually, let's do this before I go into this, just to kind of see this concept of overriding methods. So I can come in and I can override a method. Because maybe like, you know, a human, when a human breathes, they can kind of do it consciously, like breathing in slowly. There's probably maybe something specific to a human where they consciously can like, and really with intention, like control their breath. So what I can do is I can override a method in my class. So let's make a dog. So I'm going to make a dog. So like whatever dog's tail is 1 foot. Fido. Okay. Fido's 3 and has, you know, black hair. So what I can do now is I can have, you know, Fido breathe using that method. Breathing in slowly. Why is my, oh, that's, why is my dog, why is Fido breathing in slowly?
Because you didn't change it from human dot new.
Yeah, he's set to a human.
Yeah, Fido is a human, so I need to do dog.new. So my human is breathing in slowly because they're in yoga right now, and my dog is just breathing in because it doesn't really ever do yoga. So I can override a method. And how I override a method is I just call it in, I can just define it in my class, in my subclass, and it'll override it. Now, we're not going to do this next one, but I kind of just want to show it because we're going to see it in React when we get to React. And so I kind of want to show, like, at a high level, why might you want to do this? So what I'm going to do is I'm going to define a method called speak. And I'm going to say you must find this in subclass. So I'm creating a method called speak. So I'm just going to have this, you know, this, I'll just say this raise throws an error. So it like breaks your code. So if I do a puts like Fido.speak and like my Bob.speak, I'm going to get that error. So I raise an error, speak. You must define this in your subclass. That's the message I gave it. So I'm throwing an error. So what I'm saying is, hey, you essentially you need to override this method if you want to use it. Because when I'm defining my mammal class, I can say, hey, you know, all mammals probably, this might not be 100% correct, but all mammals speak. They just speak differently. Like when a person speaks, you know, they might say like, hello. When a dog speaks, you know, they're going to say rough. So I can almost force, if you inherit from a class, I can almost like, you know, force you to define a method. And we're going to see this with React React is going to force us, if we inherit from their class, it's going to enforce us, or it's going to force us to define a render method in our class. Cool. I think I'm going to let's take a break here and I'll Slack this out. Let's come back. Let's just call it 10:55. I'll stick around if there's any questions. If not, you can take a little break.
Okay.